Hello, this is Jack Jackson. We're going to be looking at the derivative of cosine function today. We're going to do this in a way similar to the way we did the derivative of sine. Very similarly, first thing we're going to look at the cosine function and then just graph its derivative on the calculator, at least graph a symmetric difference quotient, by putting y1 equals cosine of x, y2 equals the derivative of y1 with respect to x. One warning, once again, anytime we're doing anything in calculus with trig functions or inverse trig functions, make sure your calculator is in radian mode. And here's a look at the graph. The dark one is the original, and here's the derivative here. Or down here in this picture, the blue function is the original, and the red is its derivative. And notice some characteristics that we would expect to have happen. Like the sine function, this is a nice little wave going here. It's periodic. Every time it reaches a maximum or a minimum on the original function, then of course the original function has a horizontal tangent line. It has zero slope, so it has a derivative has a value of 0. So every time the original function has a maximum or a minimum, in this case that occurs at multiples of pi, then its derivative is going to be crossing the x-axis. Now, anytime that the original function is hitting the x-axis, it also turns out to be an inflection point. Since it's an inflection point, that x value will be a maximum or minimum of the derivative. So take a look at that. What does that red function look like? That ought to look very similar to something you actually should. It looks exactly like something you've seen before. Well, it's not sine, but it's actually the opposite of sine. Okay, so it looks like the derivative of cosine x is the opposite of sine x. So we can check that by putting opposite of sine x in y3, check our tables for y2 and y3, and sure enough, they are matching. So that's a good thing. Looks like it's all checking out. Now let's actually prove this. Now, we're going to use a special sum identity. Cosine of x plus h equals cosine x times cosine of h minus sine x times sine h. And we're going to use the same two limits that we did in the working with the derivative of sine. The limit as h goes to 0, the cosine of h minus 1 over h is 0, and the limit as h goes to 0, sine h over h is 1. So those three things right there are going to be the key facts. Now, of course, we start with the formal definition of the derivative. The derivative of f of x is f of x plus h minus f of x over h. Take the limit as h goes to 0. This function f is cosine function. So we have cosine of x plus h minus cosine of x over h. We're going to take the cosine of x plus h and apply the identity that we just talked about above, the sum identity. And so this is cosine of x times cosine of h minus sine of x times sine of h. Of course, we still have minus cosine of x. So cosine of x, we have the h in the denominator. We still have the limit as h goes to 0 and the equals out front. Now, like we did with the sine, we're going to group this together. We're going to put the first and last terms together and leave the middle one by itself here. On the first and last, we can factor out a cosine of x, leaving cosine of h minus 1, and then we're going to put both of these over h. In this case, the sine of x we could bring out if we wanted to. Now we take the limit as h goes to 0, so we get a limit of the sum, or the difference of these two things is the difference of two limits, provided those two individual limits exist. And we also have the fact that cosine x and sine of x do not have an h in them. So as h changes, they remain constant for a specific value of x. So that can be brought out from the limit sign. So this becomes cosine of x times the limit as h goes to 0, cosine h minus 1 over h, minus then sine of x times the limit as h goes to 0, sine of h over h. Now these two limits are what we just worked out before. The first one is 0, the second one is 1, so this first term goes away altogether, and then we get the opposite of sine x, just like our picture above suggested. So far we have these two important trigonometric derivatives. The derivative of sine x is cosine x, and the derivative of cosine x is the opposite of sine x. And we're going to use these two derivatives really along with some other properties of basic trig identities and some of our other derivative shortcut rules to derive the derivatives of the other four basic trigonometric functions. We'll come back and do the one for tangent in the next video.